Okay, each morning the probability that it rains is 2/3. If it rains, the probability that Asher walks to school is 1/7, and if it does not rain, the probability she walks to school is 4/7, and I have to complete the tree diagram. So a 2/3 chance of rain means a 1/3 chance of no rain. A 1/7 chance of walking means a 6/7 chance of not walking. Now we were told that if it does not rain, the probability of walking is 4/7. So the probability of not walking would therefore be 3/7. So I've completed the tree diagram. We're now going to use this to help us with the question they're asking. Find the probability that it rains and Asher walks to school. Well, that's this possibility up at the top, over here. So that is a 2/3 chance of rain put together with a 1/7 chance of walking. I need both those things to happen, so it becomes 2 out of 21. Now I want to find the probability that she does not walk to school. Well, both of these endings to the tree diagram lead to her not walking to school. This one is 2/3 times 6/7. This comes out as 4/7. And this one comes out as 1/3 times 3/7, and that comes out as 1/7. She does not walk to school if this happens or this happens. So I have to add those two together. 4/7 plus 1/7, that's 5/7. We want to find the expected number of days she does not walk to school in a term of 70. Well, she does not walk to school 5/7 of the time. 5/7 of those 70 times. So we would expect her to not walk to school 50 times. Now we want to find the probability that it rains on exactly one morning in a week of 5 days. So the probability of rain is 2/3 on any given day. Each day the probability of rain is 2/3. Now this is quite a tricky question. If it rains, that's a probability of 2/3. We need that to happen once. On the other days, it needs to not rain. And the probability of not raining is 1/3. That's got to happen on 1, 2, 3, 4 days. Now this that we've written down over here could be thought of as the probability that it doesn't rain on Monday. No rain on Monday, rain on Monday, and no rain Tuesday, Wednesday, Thursday, or Friday. However, it could also rain on the Tuesday and not on the other days, the Wednesday, the Thursday, or the Friday and not the other days. So this would then have to get multiplied by 5 to represent the probability that it rains on one of those days, Monday, Tuesday, Wednesday, Thursday, or Friday. So, if I type this into the calculator, I've got 2/3 times 1/3 times 1/3 times 1/3 times 1/3. And then all of that has to get times by 5, giving me 10 out of 243. It's very, very easy to miss the idea that we have to times by 5 in this question. So once again, I'll explain. Working out the probability that it rains on Monday, that will be 2/3. It would then have to not rain the rest of the week. That means I've got to times by 1/3 4 times. Of course, you could write this as 1/3 to the power of 4. But that's only the probability that it rains specifically on Monday. I also have to consider it raining on the Tuesday, or the Wednesday, or the Thursday, or the Friday, and not raining the other days. So it essentially multiplies that result by 5. So quite a tricky one, but that's how it's done. A bag contains red beads and green beads. There are 80 beads altogether, and the probability that a bead chosen at random is green is 0.35. I want to find the number of red beads in the bag. Well, let's treat this 0.35 for a second like a percentage. 35% of the beads are green. So 35% of 80, or 0.35 times 80, will tell me the number of green beads. 0.35 times 80 is 28 greens. So if we take 28 away from 80, we'll get the reds, and that comes out as 52. Marcos chooses a bead at random and replaces it in the bag. He does this 240 times. We want to find the number of times he'd expect to choose a green bead. Well, he chooses a green bead 35% of the time. 35% of those 240 times, he'll get a green bead. So 0.35 times 240. And that gives me 84. That's how many times he'd expect to see a green bead. A different bag contains 2 blues, 3 yellows, and 4 white marbles. Homer chooses a marble at random, notes the colour, then puts it back in the bag. She does this 3 times, and we want to find the probability that all 3 are yellow. Now, all 3 are yellow is pretty straightforward. First of all, we have to notice there are 9 marbles in the bag, 2 plus 3 plus 4. And of those 9 marbles, 3 are yellow. So her chance of a yellow marble is 3 out of 9. She wants 3 out of 9 the first time, the second time, and the third time. So we're going to times this by itself 3 times. And that comes out as 1 out of 27. Now the next part is tricky. All 3 marbles are different colours. She needs a blue, she needs a yellow, and she needs a white. And they all get times together because they're all different colours. But that's assuming she picks a blue, and then a yellow, and then a white. She could, of course, get a blue, a white, and a yellow. Or she could get a white, a blue, and a yellow. Or a white, a yellow, and a blue. Or a blue, yellow, white. No, I've already done that one, sorry. A yellow, white, blue. Or a yellow, blue, white. There are 6 different ways that these different colours could come out. So I have to times my final answer by 6. Once again, this is thinking about the number of different ways in which this can happen, and it might be very helpful here for you to draw a tree diagram to help to organise your thoughts. So altogether that's 16 out of 81. That's her chances of that happening. Yet another bag contains 2 green counters and 3 pink counters. Now Teresa chooses 3 counters at random without replacement. And I want to find the probability that she chooses more pink counters than green counters. Okay, so let's think about the different ways this can happen. She could obviously pick 3 pink counters. Or she could pick 2 pinks and a green. So she could go pink, pink, green. Or she could go pink, green, pink. Or she could go green, pink, pink. And those are the only ways in which this can happen. Now she's also not putting the counters back after she takes them out. So we have to think about the total going down. So pink, pink, pink. That would go 3 out of 5 times 2 out of 4 times 1 out of 3. As the number of pink counters goes down and the total goes down. So that's our pink, pink, pink possibility. And that's all going to come out as 3/5 times 2/4 times 1/3. So if we times all that together, we're going to get 1/10. Now let's look at pink, pink, green. 3/5 for getting a pink, times 2/4 for getting a pink, times 2/3 for getting a green. Now that's all going to come out as 1/5. So that's one of these possibilities, but if I times it by 3, I'm going to get the others included in there as well. so 3/5 altogether. So she has more pinks than greens if this happens or this happens. So I have to add these together. And altogether then, 3/5 is the same thing as 6/10, so that's going to be 7/10 altogether. So a lot of these questions are really seeing if we're aware of this idea that things can happen a number of different ways. And hopefully that's becoming clear as we do more examples. Simon has 2 boxes of cards. In one box, each card has one shape drawn in it that's either a triangle or a square, and in the other box, each card is coloured red or blue. Now this question is going to get some algebra involved, and I think I'm going to approach it and the rest of the questions in the final video.